What if I told you that you could predict house prices using just a few columns of data and a single ML model? Welcome to the world of linear regression. And today we're going to build a complete model, step by step, to estimate house prices like a data scientist. Let's get started. In this tutorial, we'll cover everything from what linear regression is to how to use it to solve a real world business problem, predicting house prices. We'll walk through understanding the algorithm, prepping the data, building the model, and making actual predictions. Let's start with the core idea. Linear regression is a mathematical model used to predict continuous outcomes. It assumes a linear relationship between independent variables, like square feet, rooms, and a dependent variable, price. It's one of the most trusted models in ML and data science because it's interpretable and simple to train. Let's define our problem clearly. We want to predict the price of a house based on location square footage, bedrooms, bathrooms. Our dataset includes approximately 15 variables, but we'll start simple with 3 to 4. Goal: accurate price prediction with minimum error. First, we need to import our dataset. In this case, I'm using a CSV file with house price data. You can download similar datasets from Kaggle or use your own. Let's preview the first few rows to make sure everything loaded correctly. Before we do any cleaning, let's understand what features we have and if anything needs fixing. df.info, df.describe, df.isNull, .sum function. This helps us find missing values, spot outliers, and understand the data types. We don't want our model breaking because of missing data, so let's drop. I will use df equal df dot drop in a function, and that one to drop rows with missing data. For now, I'll keep it simple and drop nulls, but filling with median is safer for real deployments. This will show the exact column names in your dataset. Print df.columns. Now, let's pick the features we want to use to predict house price. I'll start with square footage, bedrooms, and bathrooms. You can always add more features later, like neighborhood score or year built, but it's best to start small. Now let's create a linear regression object. Think of this like creating your AI intern ready to learn. Now, we train it using .fit function. This is where the learning happens. Always split your data before training the model. Without that, you're trying to fit on undefined variables. At this point, the model has figured out the best fit line through your data. It's now ready to predict. Training a model is only half the story. You need to evaluate how well it performs, or it's just guessing in the dark. In regression problems like this one, we don't use accuracy. We use metrics like mean, absolute error. Let's code the evaluation. First up, mean absolute error. It's the average distance between your predicted price and the actual price. So if your model predicts $300,000 and the real price is $310,000, that's a $10,000 error. Lower is better. If you get an MAE under $20,000 on house price data, you're doing great. Next, root mean squared error. So if your model makes one really bad prediction, like it's off by $150,000, it will spike to reflect that. It's more sensitive to outliers. And finally, R-square score, or the coefficient of determination. This tells you how much of the variation in house prices your model can actually explain. So, you've built your model, trained it, and even evaluated its performance, but where can you actually use it in the real world? Let's look at how linear regression powers decision-making across industries. This isn't just theory, this is revenue, risk, and reality. Investors use regression to estimate home value based on size, location, condition, and features. If your model says a property is undervalued by $50,000, that's your competitive edge. Banks and lenders use models like this to predict a borrower's default risk or property value. If your predicted value is too low, the loan gets rejected. Too high, risk increases. That's why accuracy matters here. So don't think of linear regression as just a school project. It's a real decision making engine that powers billion-dollar industries.